Hello and welcome back. Today we're going to look at Bernoulli versus combinations. So far, we've seen some probability problems dealing with permutations, combinations, and binomial distributions, which are otherwise called Bernoulli problems. As you saw with the Bernoulli problems, it dealt with only combinations. Okay, so today we're going to focus on really what is the difference between when you use Bernoulli versus when you use one of the combinations problems that we did in lesson 4.1b. So let's go ahead and take a look at this first example. Okay, so the first what we're going to do is we're going to determine whether or not the following situations are using combinations or Bernoulli. And the way you're going to do that is by looking at if the probabilities are fixed or not fixed. Okay, combinations, they're not going to be fixed probabilities. Bernoulli, however, as we mentioned yesterday, one of the properties of Bernoulli is that it always has a fixed probability, meaning that for each trial, the probability that you're looking for will not be changing each time. Okay, so that's really the question you're going to be asking yourself. Is the probability fixed or not fixed? So looking at this first problem, from a group of 3 boys and 4 girls, 3 people are randomly picked to attend a conference. Find the probability that at least 2 girls are picked. Okay, so this one is going to be a combination problem. Okay, and the reason why it's combinations versus Bernoulli is because once a person is picked, the probability of choosing the next person changes. Okay, if you pick a boy, then you have one less boy. Okay, so the order is still not important in the way you pick it, so it's not a permutation. But because when you pick someone, you can't pick them again, the probability changes. Okay? And so what we're going to do is we're going to set it up just like we did before. Okay, at least 2 girls means we can have 2 girls out of the 4, but we're choosing groups of 3, so we must therefore have 1 boy out of the 3 boys. And we're going to add that to 3 girls out of the 4. Which would therefore be 0 boys out of the 3. Groups of 3, so these first 2 numbers should add up to 3. Total of 7 people, so that should add up to 7. Alright, so now let's write this as a combinations problem then. So since we have addition, we're going to have a numerator, and because we're probability, we're going to divide by the total. So we'll have 4c2 times 3c1, that came from there. And we're going to add it to 4c3 times 3c0, which came from the second possibility, 3 girls chosen. And we're going to divide that by the total, which is 7 total people taken 3 at a time, 7c3. Remember, this 7 right here must be found by adding the first numbers of each term. This is one term right here. And then this 3 is always found by adding these 2 last numbers. Okay, if those don't match up, then you don't have the correct values in here. So double check that. Okay, so let's go ahead and calculate what this is going to be. 4c2 is 4 times 3 divided by 2 times 1. So let's cancel the 4 to make it 2. 2 times 3 is 6. 6. 3c1 you should know by now is just going to be 3. 4c4 is the same as 4c1, which is 4. And 3c0 is 1. Anything with an r value of 1 is always going to be 1. And then 7c3 in the bottom, so let's do this on the side. 7 times 6 times 5 divided by 3 times 2 times 1. Well, the 6 cancels with the 3 times 2, leaving just 35 in the bottom. So we have 18 plus 4 divided by 35. Gives us 22 divided by 35. Now I did specify that I want you to round off probabilities to the nearest thousandth. Okay, so if you do that in your calculator, type in 22 divided by 35, you will get approximately 0.6285714 286, because it keeps on going. So to the nearest thousandth, the probability is 0.629. Alright, so that was a combination problem again because once a person is picked, the probability of choosing the next person changes. Because you can't pick them anymore. Okay, so pause the video and write down anything you need to. Okay, let's look at number 2. From a group of 5 men and 3 women, 3 are randomly picked to sing for the class. All people are eligible to sing more than once. What is the probability that at least 2 women sing? So it looks very similar to that last problem, right? We have different number of men, different number of women, but you're still looking for probability at least 2 women sing. Now you want to ask yourself, is the probability of choosing a woman to sing going to be fixed or not fixed? And the clue here is they're eligible to sing more than once. That means that they can be picked again, which means this is a Bernoulli. This is a fixed probability. Bernoulli. Okay. And again, the reason for that is because the probabilities are fixed because someone can sing more than once. Okay. So for Bernoulli, we're going to set up our NRPQ. Now we're looking for the probability that at least 2 women sing, and we're choosing a group of 3 randomly picking. That 3 randomly picking is going to be our n value, and at least 2 women singing is going to be 2, 3. Now be careful here. The probability of success is going to be the probability that you choose a woman, okay, to sing. So we have to look at the total numbers. We have 3 women out of a total of 8. So the probability of choosing a woman to sing is going to be 3 out of 8, which means the probability of failure is going to be 5 out of 8, the complement of 3 over 8. Remember, these P and the Q values must add up to 1. So let's go ahead and, and by the way, notice that if you would write this as decimals, you would have 0.375 and 0.625 accordingly. Now, when we're going to be raising these to the 3rd power and such, we're going to get a lot of digits. So what I'm going to do is I'm going to stick to the fractions. And that actually will make my work a little bit easier to deal with. Okay. So this is one of those cases where fractions are a little bit better. So using Bernoulli, we have 3c2 3/8 to the 2nd power times 5/8 to the 1st power. Okay, we're going to add that to 3c3 3/8 to the 3rd power times 5/8 to the 0th power. Remember, those exponents must add up to your n value. And that first exponent of each of them is going to be the same as your r value. Okay, so let's calculate what these are going to be. 3c2 is the same as 3c1, so it's going to be 3. 3/8 squared is going to be 3 squared, which is 9, over 8 squared, which is 64. And 5/8 to the 1st is still 5/8. 3c3 is 1. 3 cubed is 27 over 8 cubed, which is 512. And then 5/8 to the 0 is 1. Okay. And remember, when you're dealing with fractions, the denominators in your overall fractions are going to be the same. Okay, because you have 8 squared times 8 to the 1st, which is 8 cubed, and so forth. Okay, so we get essentially a denominator of 512 for both of these. And if you do 3 times 9 times 5, that gives you 135. And then the next one's going to be 27. Combine those together, we get a fraction of 162 divided by 512. Again, we're rounding all these probabilities to the nearest thousandth. So let's find that in the calculator. So type that in. 162 divided by 512. And that should give you 0.31640625. Dot, dot, dot. Hey, look at that. I can go in the black region. That's kind of cool. Alright. So to the nearest thousandth, 0.316. Alright, again, this one was a Bernoulli problem because the people are eligible to sing more than once, so that means the probability is fixed. Pause the video, write down anything you need to. Okay, one more problem. A business makes a certain part for a machine. The defective rate is 10%. 10 parts are sent to a distributor. Find the probability that at least 2 parts are defective. Now the question is this a fixed probability or is it a not fixed probability? Does the probability change or not? Okay, and this one is going to be a Bernoulli. Because the general defective rate is 10%, and this would be a combination problem only if the 10 parts had the 10% defective rate. Okay, but it's they're sent to a distributor. Okay, and that's going to be a general thing you're going to be doing. Okay, you're sending parts in general to a distributor. Okay, so it's not going to be a changing probability. 10 parts are sent to the distributor, so the probability you get a defective part is 10%. It's always going to be the same. Now let's just say, for instance, you were in a shop and you had 10 items on a shelf, and the defective rate of the products in there is 10%. Once you pick an item off the shelf, then the probability you choose the defective would change. Okay, because you might have gotten the defective, you might not have gotten defective. But if you're just sending things in bulk to a distributor, that's going to be Bernoulli. So let's set up our NRPQ. Okay, the total number of the parts are sent are 10, so that's going to be my N. And you want to know the probability that at least 2 are defective. So that's 2, 3, 4, all the way up to 10. Now remember from the previous lesson, that's a lot of adding to do. So in this case, we're going to look at the complement of 2, 3, 4, all the way up to 10. Okay, namely the 0 and the 1. That's 2 things you have to add up. But we're going to subtract that from 1. Probability of success is going to be what we're looking for. We want to know at least that 2 parts are defective. Now remember, defective sometimes has a negative sense to that word, but that does not mean that it can't be a success rate, okay? Because success is what we're trying to look for, which could be a negative thing. So our defective rate is going to be 0.1, which is 10%, and our failure rate is going to be 0.9. Success is 0.1, failure rate is 0.9. Alright, so because we're dealing with the complement, we got to remember to do the 1 minus. Okay. And we're essentially doing 1 minus the probability of 0 plus the probability of 1. Okay, so probability of 0 is going to be 10C0 times 0.1 to the 0 times 0.9 to the 10. That looks like a 16. Let me reread that. Let me zoom in, that way I look a little bit better. And then we're going to do the probability of 1, which is 10C1, 0.1 to the first times 0.9 to the 9th. Remember, those exponents must add up to that 10. Okay, and this calculation is going to be fairly nice and easy. Okay, 10C0 is going to be 1, 10C1 is going to be 10. So if you type in 10 times 0.1 to the first, which by the way is also 1, times 0.9 to the 10th, you would end up getting 0.3486784401. Okay, add that to, if you get, when you typed in 10 times 0.1 to the first times 0.9 to the 9th, which gives you 0.38742049. Alright, now let's add those two values together. That gives me 0.73609 89291. Technically ... because there's probably more places than that. Okay. Subtract that from 1, that gives me 0.2639010709 ... So again, nearest thousandths is going to be 0.264. Okay, pause the video and write down anything you need to. Okay, so in general, the difference between Bernoulli combinations are going to be looking at whether the probabilities are fixed or not. Combinations, you don't have a fixed probability. Whereas Bernoulli, you always have a fixed probability. Now, just keep in mind as you work on the assignment for this lesson that if you do the wrong method, you're going to get a value very close to if you did it the correct method. Because they are kind of similar in some respects. You should get similar kind of results. So when you're checking your answers to the assignment we do in class, just keep that in mind. If you got something a little bit off, you probably use the wrong method. Okay. Thank you for watching. See you in class.